So this is my code for project 2. So first is the decision tree learner. So first we have a constructor here where we get the leaf size. Uh, we create an empty tree. We get verbose if we want to see all these like helper print statements. And then features, which is just the names of each of the columns. So first we go to add evidence. And so what we do is we take two NumPy arrays for the X data, and the Y data is the features and the target essentially, and then we convert them into pandas data frames. I did this because this program was written using the previous uh, homework where we did it with pandas, and I just modified this function to convert the NumPy into pandas data frames, but the entire rest of the code, it works the same as the previous homework. So we get the X data, convert that to a data frame. We get the data Y, turn that into a series, and then concatenate the two. We also save the names of the features into this features array, and then we build a tree using the data, the names of the features, and the target. And so how that works is here in build tree, we check if we've reached the base case, right? We've reached the leaf size we desire, and if so, we just return that as like the node in the tree. If not, then we calculate the correlations of the tree, of the features to the target here using the pandas correlation function. Then we get the best feature using the select best features function based on the correlations and the features, and a method which I'm just using alphabetical if there's ties. And then using the best feature, we split the data at the median for that whatever feature that is. Then once we've split it on the feature, we set the left data to everything left less than or equal to the split value, and then the right data to everything greater than the split value. And same with the target function. We split the target function similarly. And then if the new function, if the new data subsections, the new nodes are the same size as the existing nodes, or sorry, they have the same mean as the current node. That means we've just created the same. We haven't split the data at all, which means that the function is not able to split further. I added this for the bag learner, which can have multiple data points with the exact same value. So this prevents any recursion errors for that problem. Then the left tree and right tree here, we just run the same thing recursively. Now, how do we pick the best feature? We do that up here and select best feature. So we take the correlations and we look at just the correlations to the target function. We get the absolute value and then sort those values in descending order. Then we just pick the first value and then we check if the first value is the same as the second value. If it is, then we append them to this tied features list, and we do that for every feature that is tied to the best, that is tied for the best correlation to the target value. Then once we've done that, we check for the first. We just pick the first value alphabetically if the method is alphabetical, randomly if our method is random, or first just the first one that appears in the list if the method is appearance. But regardless, we check for that. We just pick the first one in the list and then just return that. And that's how we pick a sorted feature in the build tree function. So that's how my decision tree learner works. Oh, and sorry, also there's query here. When we're querying the points, we create an empty NP array that is the same size as points, and then we create, and then for each of those, we in that size of that array, we create a series using the points data, and then we just go through the tree. We run through the tree, and then we do that for each point because each point is a different estimation that we're trying to predict. So we do that for everything. Save the final prediction in the predictions array, and then once we do that, we return the predictions array, and so we'll have for every like guess that we're using the query, we have a predicted output. Sorry. Then there's also these functions here to visualize the tree as like a diagram, which is used here to visualize the tree. You can see that in the test learner. It's the same as the homework from last week. Then in the random tree learner is pretty much the same as the decision tree learner. The only difference here is that in build tree, instead of using select best feature, we use select random feature, which as you can see here is just selecting a random choice from the features list. That's it. It just picks a random feature and then we split on that feature and that's it. Everything else works identically to the decision tree learner. And then finally, we have the bag learner. Now, the way the bag learner works is we get a learner, we have a learner key, KW args, some bags, a boost. I didn't implement the boost, it was optional, so I couldn't implement it. And then the verbose flag. And we save all those to the thing alongside, uh, that's it, right? Alongside the features here, name, which is necessary for a different portion. And so first what we do in add evidence is we just get the X data converted to a data frame and get the name of the features similar to the decision tree learner. And then we create a sort of temporary learner here. And then we set it to whatever the self.learner type was. So we'll just check here very quickly. You can see, for example, here it's dt.dtLearner. So it would run the constructor based on, the keyword args of the other function. So then after we've created it, and if we don't have any keyword args, for example, the linear regression learner, then we just don't give it any args because that can cause issues with the constructor otherwise. So then we get the bag index. We just randomly pick things from the bag, and then we randomly pick points in the bag, and then we create the bag by getting those data out of the data X and data Y, and then we just use those bags to fill out the learner, save that to the learner's array, and then that's it. We just loop that over for however many bags we want, and then that's our collection of learners that we can use to aggregate our prediction. So in query, we just go through that learners array and just predict using the query function of whichever learner we are using, just predict an outcome for each of the individual learners, save that to an array, then use np.mean to get the average of each row for that prediction, and then return the average predictions, which just means, what the overall and what the estimated median answer, or mean answer, I should say, for the that input and output should be. Then finally, we have the test learner. I didn't show the linear regression learner because it was already provided. I haven't changed anything here. So it's the exact same as the given code. I didn't change anything other than adding my name to the author method. So then test learner, this is the testing file that allows you to actually calculate this information. So first we calculate RMSE here, which is the root mean squared error. So that was already given. And then here I also added mean absolute error using absolute value of the mean. The accuracy was calculated here, right? You get the number of correct predictions, the total number of predictions, and then calculate how many of them are accurate basically. Then you got the confusion matrix here. I couldn't make the confusion matrix work, so this, while it's implemented, it doesn't actually work, so I just had to comment it out. Yeah, I could not figure out how to make this function work. It's pretty much how I did it in my previous code, but it just kept giving me errors, so I have no idea how to make it actually work properly. Then finally, here's correlation. This was also provided. I just moved it into a separate function as well. So finally, here's the actual test. So you have to use it in this method where you use a file name and then a type that's either classification or regression. And well, normally if you wouldn't do that, it would exit out. But for just simplicity in this demo, I have just provided values that I will switch to show both regression and classification. But normally you would give it and it would use your args, system args, and then it would basically split them into an NP array based on the data you got. Then split that data roughly at about the 60% point between the training data and the testing data. And then, so here's where it actually does. If you are doing regression only, since you can't do a linear regression learner with classification data, you would it would create a linear regression learner, print the author, add evidence, and then evaluate an in-sample result based on the training. It will do predictions based on the training data, and then predictions based on the testing data, which is in sample and out of sample, and print those results. Then we create a decision tree learner, and then do the same thing here where we train it. We also visualize the tree, so you'll be able to see an image of the tree later. And then if we're doing classification, we'll calculate the accuracy in the confusion matrix, although I wasn't able to get the confusion matrix working. And if we're not doing classification, we're doing regression, which means we want the root mean squared and the mean absolute error. And then regardless, we'll calculate the correlation as well. And we do the same thing again for the out of sample test. And again, everything the exact same here for the random tree learner as well. And then for the bag learner, specifically I used a DT learner with 5 bags and a leaf size of 100 because the data I used was quite large, so it would have recursion errors if I used smaller numbers. But yeah, so we do the same thing. We check if it's classification and do accuracy. Else, if it's regression, we do root mean squared error and mean absolute error. And that's what we do. So if I run this program, first I should note my data. I used a house price regression data set for regression and a phone classification data set for my classification. So if I run this here, for my house price regression data set, we'll just see a decision tree here, and then a random tree after that. And then also in the output, you can see the linear regression results for, all of the data. Same with the decision tree, the in sample, out of sample, random tree, in sample, out of sample, and bag learner, in sample, out of sample. And then again, we can just quickly comment this out and introduce the classification data set, which is just a bunch of phone data. Take a little longer because it's a bigger sample. And we can see here another decision tree, another random tree, and then the output here, again, we can see the accuracy correlation, accuracy correlation, accuracy correlation for all the different sets. So yeah, that's everything I did.